Testing now. Okay. I'm hoping someone can hear me now. Hey, wow. So we'll roll all of that back. Lesson 1, don't upgrade your operating system less than 24 hours before your live stream. Can cause problems. So apologize for all of me just blathering on, which uselessly, unless people could read lips. And we'll start back at the beginning. I'm still Clark Richey, but now you can hear me, and I'm the graph guy. Apologies for obviously the sound issue. Apologies for a lower quality picture today, as I also have, surprisingly, or not surprisingly now, some camera issues. My higher resolution camera is not being picked up properly by Twitch Studio under Windows 11. Don't know why, just discovered it. I'll get that fixed for later on. And so what we're going to do today, so no puppy cam as well. Sorry, because I'm down to one camera, so no puppy cam. Next time. Also a little bit of housekeeping. We're going to soon have a website up where I'll be able to share the content that is created here. The videos will still stay on YouTube for watching after the fact. This will be more for things like the pickled cherry pepper recipe that I had last time, the list of some graph modeling best practices, as well as some of the content that I'm going to be sharing with you today. This will also prevent you from having to watch me do a lot of typing, because that's neither fun nor particularly informative. So today we're going to be talking about some criteria for choosing the database that you want to use in your project. Now, interestingly enough, while in this podcast, of course, we are particularly interested in graph databases, this criteria is really general to pretty much any database. I have a long background in databases. For those of you who may not know, in full disclosure, I used to work for a database company for about 5 or 6 years ago, where I ran pre-sales engineering. So I have some experience in this. I'm not saying I'm the world's largest database expert, but I think the criteria we're going to go over today should give you a really good starting point, whether you're looking at a graph database or really any other type of database. So diving right into that, the key thing, like in really any other software endeavor, is understanding your use case. Why do you need a database? What are you going to do with it? Are you going to be doing streaming data? Are you doing transaction processing? Is it an OLAP problem? What exactly are you doing with it? This is crucial because, of course, this is strongly going to influence how you weight different criteria. So for some use cases, for example, the security might be critical, whilst for others, it might be really completely inconsequential. So, that's really, really important to keep in mind, essentially, I think. So I'm going to give you some general criteria. I'm going to then go over as well what I believe you should use in terms of, or rather what I like to use in terms of how I kind of rate the different criteria, so that kind of gives you a baseline for things. So this is the one that's really particular to graph databases, and that, of course, is your database a native property graph database? So what do I mean by that? There are a number of databases on the market that will tell you they're a property graph database, and that's true. Cosmos DB by Microsoft, for example, is a property graph database, amongst other things. Oracle has a property graph database. However, not all databases, not all graph databases, as a matter of fact, most property graph databases at this moment are not native. And what that means is if you look at the core of the system, the actual architecture by which they're storing the data, it's not stored in a graph structure. It's typically stored in a table structure. So so Oracle's, for example, is stored in a table structure. Cosmos DB under the covers is actually a JSON database. Their structure for the graph is JSON under the covers. Whereas other databases, Neo4j, memgraph, for example, TigerGraph, these are native property graphs. Their core data structures are actually graph structures. They're nodes and edges. They're not just applying a facade of a graph on top of another layer. Now, that might be okay, but let's think about the implications of that. So if your property graph database is non-native, that comes with some overhead, right? They're essentially giving you a graph facade, an API that presents the underlying structures in a graph way, so that you can query them and store data and think about the database in that way. But under the covers, they're translating that into what's actually happening in the core engine. And like anything else, that work comes with a cost. What that cost is going to be is absolutely going to vary depending upon the database, but it's always going to be there. In some cases, it might be very high. Right? One of the reasons we like property graph databases is our ability to traverse many, many relationships very, very quickly, whereas that's really hard, if not impossible, to do in, for example, a relational database. Well, if my core structures under the cover are actually relational, how good is my performance really going to be in going many, many degrees of separation? Probably better than if I try to create a graph schema, or rather a relational schema, to do that myself, because the people who did this obviously have deep, deep knowledge of their native database. But most likely, almost 100%, not as good as if it were native structures. That may not matter to you. You may, as a matter of fact, need a multi-model database. You may have a graph use case, as well as a document use case, or a columnar or relational use case, and you may want a database that can do both of those things to a greater or lesser degree. So multi-model might be okay, in which case you're dealing with a non-native property graph. Just be aware again, anytime you're doing multi-model, you're kind of choosing a generalist, right? It's like going to the doctor. When you go and you see a general practitioner, they know typically a little bit about a lot of things, but they're not experts in any one particular area. So they might refer you to a neurologist or to a gastroenterologist or somewhere else, depending upon your specific issue. The same is kind of true of the multi-model database. They tend to be pretty good at a bunch of things, but they're not the best at any one thing. So if you really, really need high performance or some other kind of really key high-level functionality in a particular model, like document or graph, multi-models, the trade-off there might not be worth it for you. Something to bear in mind. Second criteria, and I'm not going to spend a lot of time on this, is cost. And I make it the second because this, depending upon your situation, can really narrow your playing field. If you really have no dollars to spend on this, you've got to find something open source, or at least with some kind of community edition where it doesn't cost you anything. It's going to narrow down your choices. Like anything else. Performance. Performance is the third criteria I like to look at. Performance is a tough one. Everyone likes to go and look at benchmarking to see which database is faster. That's tough, right? Benchmarking things is really a rabbit hole, if you ask me. There's a number of ways to go about this. So let me share some things with you. So here's a page. This is the one of the pages from the actually here, let me go here for you. So this is actually not what I wanted to show you. There we go. So this is the LDBC group. The LDBC is, let me go back to their homepage here. The LDBC Council is a non-for-profit group that is interested in linked data, particularly linked data benchmarking. They are the Linked Data Benchmarking Council. And they've been around for a number of years, and they try to put together sort of standard benchmarks for people to use when comparing linked data databases. Initially, this was very much, of course, in the RDF space because RDF came out first. It has been picked up to a greater or lesser degree by the property graph community as well. And if you look on their site, you can see already there's a number of different types of benchmarks. And this gets into one of the problems, and it goes back to my first point of know what you want to do, understand your use case. So you see they have graph analytic benchmarks, semantic publishing, social networking, and so on. The type of data you're going to benchmark against is going to impact your benchmark. So you have to understand that. And even though this is a, if you go into, say, for example, graph, they call graph analytics, and they define what they do here. And again, this site they do a very good job in this organization of really defining their benchmarks. They tell you very clearly what they're looking at. So here they tell you these are the algorithms that they care about and use to test. They tell you why they do that, and so on. Again, it's a good site. But if you don't fall into one of their very specific use cases, you're kind of in a little bit of limbo. So if you're not particularly interested, if what you're doing is, kind of social networking, but maybe it's a little bit different, well, their social benchmarking data, and again, they provide data and methodologies for people to use to benchmark databases so that you can, in theory, compare apples to apples, right? So if I use the LDBC's Graphalytics benchmark suite against database 1, I can apply it against database 2, compare the results, and theoretically, I can have a good non-biased comparison to say which database is faster. So that's what they're doing. The thought is good, but the problem, unlike many things, is the implementation is always flawed at best. And so what do I mean by that? Well, if you just start Googling for benchmarks, so here's one that was put out by TigerGraph. And TigerGraph is benchmarking themselves against Neo4j. And here's one of the number one things you're going to see all of the time is that benchmarks tend to be put out by sort of two different groups. The primary group are by database companies. And this may come as a surprise. When a database company puts out a benchmark, their database is always the fastest. Shock, right? Big surprise. So here TigerGraph is saying, they're the faster one for different workloads and so on. We can go over here and we can find ArangoDB. And if we scroll down, make this bigger, here's Arango showing how they're a faster database than everybody else. And yes, they've picked some different databases as well. Point being, there's no good reason to believe a database vendor that tells you they're the fastest. And there's a lot of reasons for that. One, if I'm a database vendor, I'm never going to publish a benchmark that says, hey, you know what? We're the 15th fastest database. It's a terrible idea. The other gets to the point that benchmarks, in my opinion, are essentially meaningless when they're published in this way for a number of reasons. One, again, they're taking a generic use case or one that they've created to make their point. And that use case is probably not your use case. It's whatever data they've used, whether it's the LDBC data set or something else that just happens to really fit well with their use case. And that's a problem. The other problem, and you see this from in particular from our second category of benchmarkers, which are just regular developers like you and I, who try to contribute to the community, and they're running some tests, they publish them out. to the world and say, here's what I found. Well, in both cases, and in particular the second, what you get are people running tests where they really understand how to write those performance tests for a particular database, but not for the other. So using this picture here, just because it shows a lot of different databases, I may have a really good understanding of Rango and Mongo, but not understand Orient, Neo4j, or Postgres very well. So my queries are really optimized nicely for Rango, and Mongo, but are really, really poorly written for Neo4j and Postgres. And of course, if I write bad queries, that's not a fair analysis or representation of the database running those queries. That's a reflection on my bad queries. And trying to find someone who's an expert on multiple different databases and actually takes the time to optimize the queries for those different databases is extraordinarily, if not impossibly, hard to find. That's a massive amount of work to do. And then you face the problem. Let's just say someone does that and gives you a nice chart like this. Well, what version of the database? By the time someone does that and gets it done, and then you find it, odds are really, really high the database you're looking at is another version beyond that. And does that make it faster? Is it slower? Is it the same? You have no idea. So you're kind of back to square one. So I'd be very, very leery of benchmarks. If you want to look at something kind of like that, what I do kind of like to look at, I like to look at over here, dbengines.com. What they provide is a ranking, not by performance, but by popularity. Now, obviously, picking your database engine should not be a popularity contest, but there is very likely some good information present in here. If no one is using the database you're really seriously looking at, and it's been around a long time, there might be something going on there that the community has discovered that you should be, very careful of. So this is a really nice site. You can get trend charts. You can filter it by different types of databases and so on. So if I just want to care about graph databases, I can go over here and I can see who's the number one. They tell you exactly how scores are calculated as well, so it's very transparent, and you can see the delta. So are things increasing in popularity, decreasing in popularity, and so on. It's also a nice place to go just to get an overview of a space. There's always more databases in here than I'm familiar with because people are coming and going from the space at a pretty rapid clip. So this I find better than benchmarking if I want to go ahead and start, just kind of narrowing things down. And of course, scale is going to be an issue for your benchmarking as well. If you don't need to have a lot of data in your database, you don't need to a scale benchmark, right? Many databases will form significantly different at small scale versus large scale. And if you don't care about large scale performance, well, who cares about a benchmark for large scale performance? So my next criteria becomes ease of use. This is a big one for me. And when I talk about ease of use, I'm mostly talking about setting it up. How easy is this to install on my platform of choice, whether that be Windows or Linux or whatever. Sometimes both, because I may be developing in one environment and deploying in another. Also, how is the tooling? How's the tooling support? Are there good tools to allow me to monitor the database, to manage the database, to load data into it, to query the database? I want that to be as easy as possible. And then, of course, what's the learning curve? How easy is it to figure this out? For graph database in particular, how easy is the query language? I'm a big fan of Cypher. There are others out there, obviously. Some are easier to learn than others. So does your team know the language that database is going to use? If not, how easy will it be for them to pick that language up? The fifth one, stability. How stable is it? Is this a robust database? Does it crash a lot? This also will depend upon your specific use case. In certain industries, there are very, very specific requirements around this, particularly in areas like financial services. So this gets into backup as well and recovery, potentially high availability situations. Anything that can kind of take the database down or make it unavailable falls into the category of stability. Will it keep running in the way you need it to under the kind of loads and situations that you need? Next, support. And under support, I'm talking not just about paid support, particularly if you're using open source database where there may not be any paid support, but also the community around the product. Lots of databases. The easiest way to find something like that is if to go maybe to Slashdot or oh my goodness, to some other site out there. And my God, of course, I'm completely blanking. Dog is here. Completely blanking. Some of the major ones right now, but to just Google it. Is there enough of a community out there that if I Google a question about the database, I see other people talking about the database, answering questions, having the same type of problem that maybe I do, and helping me out? How robust is the developer community around this? Because it's often easier and faster, in my opinion, to get an answer through the developer communities than to go through a support process. Now, obviously, if you're going into a production scenario, and again, stability is critical, you do want to know that if something happens in production where you need to meet your SLAs, your service level agreements, and that database has gone down or there's a problem, that you can get someone on the phone with you, on a screen share if necessary, really, really quickly, so you can get things back up and running. So definitely looking to support. What does it cost? What kind of support levels are available? And then features. Features is the last criteria I'm going to talk about. One of those features is, of course, security. I'm not going to go deeply into security. That's a whole massive topic. And again, for some applications, it doesn't really matter at all. For others, it's completely critical. And there's lots and lots of different levels of granularity and detail involved in security. So, if that's important to you, you're probably pretty much aware already of what those criteria are, and that can be a major factor. A major feature to me as well is consistency. And I am not going. We could have a multi-session on consistency, but briefly, two major types of consistency people talk about. ACID consistency, right? So that's the classic one. And we talk ACID consistency, we're talking about atomicity, consistency, isolation, and durability, right? When I create a transaction, even the transaction may consist of multiple statements. Does the entire transaction either commit or roll back? Atomicity, again, consistency. Does the database always go to a consistent state, right? If I perform an operation, does it consistently go from state A to state B the way it's supposed to? Isolation, if I have two transactions running, are they isolated from each other? Is it guaranteed that one transaction cannot side effect another transaction? And then durability, once those transactions are committed, even if something happens like a power failure or a system crash, is the system able to recover from that? Are the transactions that have been committed actually persisted in a way that they are recovered and therefore durable, they last? Those are really, really important to me. And then, of course, there's the other model of consistency, which is CAP theorem, sometimes known as Brewer's theorem. Really not going to get into that deeply, but this defines things a little bit differently in terms of consistency, availability, and partition tolerance. And really mostly applies to large-scale systems where you have to have multiple instances or partitions running where the data is distributed across them. We're really not going to delve deeply into that here. So my take on these features in terms of how I sort of rank them and why, the number one for me is stability. Especially if there are anyone who happens to be on, or someone who's working for any of the graph database companies, this is my biggest message to any of you. Please, please, please focus for a while on stability. And again, these are my preferences. I tend to work in a lot of areas where the application is mission critical or business critical. And I need to know that if I shoot that database, if the power goes down, if a hard drive explodes, a CPU fails, whatever, that the database is going to survive. Now, obviously, I'm not talking about magic. If I only have one database and it's running on one box, and that box explodes, well, sure, the database is down. But if I have a highly available cluster, typically three or more instances of a database in a cluster, and one box goes down, like I really, really need to know, as other two aren't going to go down. I need to know that if someone runs a query against my database, even if it's only one particular, if it's not a cluster, just one instance, that query isn't going to crash my database. It might slow it down. That's okay, but not crash it. Never crash it. I really need to know that I can, perform all the operation, that database is going to be up all of the time. Because for me, at least, if it's not up, it's certainly not performing. It's no longer easy to use because I can't use it. Your features don't matter because, again, it's not doing anything, and you're certainly not performing. So stability. Please really, really focus on stability. My next criteria for me is ease of use. I'm super busy. You're super busy. Being a software engineer is hard. We constantly have all these different things we have to learn and keep track of and so on. I don't have time to mess around with a 2-hour process to install your database. I don't want to have to use just a command line tool to configure your database. I don't want to have to mess with 14 text files that I have to edit. I don't want to have to learn 4 or 5 other technologies to run your database. I want it to be really simple because I need to focus on the business problem I have, which is not operating your database. It's doing something important for my customer or myself on top of your database. It's not running your database. So I really want it to be easy to use. I need to have good tools so that I can move on to the important things. Features. Features are certainly important. For me, again, because I typically work in fields where the data is really important and you can't lose data, a truly ACID compliant database is very important. Some databases, in particular some graph databases, will tell you they're eventually consistent. You'll see these, for example, on some of the graph databases who are non-native and who rely on systems like HBase. And they'll tell you straight up, for the most part, that this is an eventually consistent database. And eventual consistency is a very soft guarantee, and you could think of guarantee should really be in air quotes. And what that basically means is, hey, if you're writing a bunch of data to the database, and then you stop for writing data for a long enough period of time, what that time is, no one knows. The data will replicate between all the partitions that you may have, and it'll be there. Except sometimes maybe it won't, and you can lose data in some of these databases. And if you're Twitter, for example, and I'm not saying Twitter has this problem, but for example, you're storing tweets, whatever, and if my tweet doesn't get saved, it's not the end of the world. I can write it again or whatever. If it's a banking application and that account transfer gets lost and not saved, that's a really big problem. So this depends upon the space you work in and your use case again. But for me, eventual consistency is a non-starter. I want ACID compliance. I want true consistency. And again, feature set is going to pair to use case. In the graph space, a lot of graph database companies are looking really long and hard now at advanced graph data science and machine learning capabilities built into the database. And again, that can be a really, really great capability if you need that. If you don't, it doesn't particularly matter, certainly. And this is, again, really a matter of matching up your features to your use case. And the fourth criteria for me really, it tends to be performance. And it's last for a number of reasons. One, again, when I apply the other criteria, stability, ease of use, feature set, to the things I'm looking at first, and I would say in there support as well, probably between features actually and performance, I find most of the database I'm looking at tend to drop out. I tend to be after the pretty small list by the time I get to performance. I find things that are too hard to install and to deal with. They crash a lot. They don't have the features that I need, or there's no support, whatever it might be. And then I tend to have a fairly small list, and now I can start looking at performance. And that's important because now I can start comparing it to my use case. I can see what the community is saying. And performance is the hardest to test, because even if I'm down to, say, 2 databases and I want to test this, well, if my scale is small, if I know I'm not going to store that much data in here, well, performance may not even matter, right? Most databases, particularly if you've gotten through all these other criteria, they're probably going to perform just fine at small scale. It tends to be at really large scale where performance problems really rear their head, or in particularly complex use cases. So particularly complex graph analytics. So maybe shortest path, for example, can be an issue that some databases struggle with. But again, it tends to be at a certain scale. If I have 100 nodes in the database, pretty much anyone can do shortest path because that's a trivial problem. If I have 100,000 or 100 million, now it gets real. But trying to test any database at that kind of scale becomes really hard and time consuming. You've got to create the test data, you've got to load it, and now you're back to having the problem again of, do I understand my particular database well enough to really write a good query and to get the results that I can trust that show that the database really does or does not perform, versus I don't know how to really do that. So performance is hard, and honestly, what I tend to do is look to the community here. So if I'm down to, say, 2 or 3 databases, and I know that I have a fairly good-sized sort of target scale, maybe I'm targeting 500 million nodes, for example, and 500 million nodes, and maybe 2.5 billion edges. Then I'll look into the community saying, hey, is anyone in the community using either of these graph databases in roughly the same scale? And what are they saying? Are people saying, yeah, I've done this and it's fine? Or am I seeing an overwhelming majority of people saying, yeah, I couldn't get there. Like, I hit a hard wall at a certain level of scale. And that tends to inform at least my personal decision around performance. So hopefully this was somewhat helpful. Again, most of this can apply to pretty much any database. And as soon as we have the website up, I will post this list there as well, along with all the other information. And I'm really looking forward to additional feedback. Really want to hear more from the community in terms of either questions about what we've done. The dog community is speaking right now, so that's fantastic. But topics that you're interested in, questions that you might have, so we can address those directly. And information on how to contact me is coming up as always. And I appreciate you coming by and spending some time with me. I'm Clark Richey, and I'm the Graph Guy. See you next week.